So I'm starting off today with a review of something called completing the square, because this is on your test in multiple locations. In the first place, it might just be complete the square to find the vertex. And you would go, that 4 tells me half n squared. Half of 4 is 2. 2 squared is 4. I do plus 4 and a minus 4. This part factors, and that is called a perfect square. In case you'd never made this connection before, because this is x plus 2 and x plus 2, that's what makes it a perfect square. So you can put them together and make it x plus 2 squared. And then those two together make minus 3. Raise your hand if you had that one right. Awesome. Then that tells me the vertex. Negative 2, negative 3. Are you on that? That also tells me whether or not, it tells me the range of my parabola. As long as I know whether it's a U shape or a upside down U shape. Okay, so think for a second. What would the range of this parabola be? Because now I know its vertex, I know its range. I'm picturing it, but maybe it'd be smarter to draw it. This moves 2 to the left and down 3, and it looks like that. Now from the picture, it's super easy to do the range. You go, okay, how low does it go? Negative 3 to how high does it go? Infinity. And do you get how that kind of told me the range? Okay, does this one have a min or a max? Well, again, if I draw a picture, it's easy. That's a min. It's a low spot, the minimum. If there had been a negative in the front, its name would have been max, and the whole thing would have been upside down, and then it would have had a maximum instead. Okay, now, just for kicks, fill in this sentence. The x-intercept is where y equals 0. Find it. Are you going to go and try to factor this thing? Hint, you won't be able to factor it. So what's step 1? Violet. Adding 3 to both sides. Excellent. 3 equals x plus 2, quantity squared. Step 2, Seiji.
Square the x plus 2.
As long as you mean square root.
And it makes absolute value.
Yes. Nice. And I notice you didn't try to simplify the square root of 3 as some weird decimal. You just leave it as the square root of 3. Leo, next step.
When you subtract the 2 from this one.
Oh, you forgot something. It's really important. Really, really important. Before you subtract the 2 from both sides, you make 2 equations out of it. X plus 2 is the square root of 3, and then you subtract from both sides because you need another one. X plus 2 is negative the square root of 3. It would have been easy to forget. And right there would have cost you. Nordstrom, was he right that we subtract 2?
Yep.
Yep. And your 2 answers are negative 2 plus the square root of 3. And why'd you start with that? Because if you were going to have an imaginary part, it would be the second part. So we usually put the square root part last. Besides, I'll show you why at the very end it's smart to put the square root part last. Negative 2 minus the square root of 3. And then it's easy to combine them and go, they both start with negative 2. And one's plus and one's minus the square root of 3. Does this remind you at all of that famous formula, x equals negative b plus or minus the square root? You know what I'm talking about? Well, that is today's lesson, is about that famous formula and what it does for us. Okay, but we just found the x-intercepts. Those are the x-intercepts because we set y equal to 0 back here. These are the x-intercepts. I know they look like normal x-intercepts, but we could make this a decimal and we could find out exactly where they are as decimals, but they're x-intercepts. There's 2 of them. There's this one, and there's this one, and this one's smaller because we subtract in it. Okay, so those are my 2 x-intercepts, even though they don't look like it. All right, I'm going to give you a more normal one. y equals x squared plus 3x minus 4. If I asked for the x-intercepts, you would set y equal to 0. And if you can factor it, you should. And this one happens to factor. And you're either quick at these or you're not. And if you're not, you should get quicker, because this is going to be something you use through all of high school math. Factoring just keeps coming up over and over and over. And I'm telling you, this year you're going to use it a ton. Next year, answer to almost every hard pre-calc question. Not every one, but a lot of them is, oh, I can factor it. I'm telling you, taught that class. All right, so when everybody's stuck next year, try to think back to, is there a chance of factoring's it? All right, if there's any negative signs, then there's a negative on one of these, and there is. And then you can use logic to go, it can't be two negatives, because then this wouldn't be negative. So it must be one of each. And then I got a 4 and a 1. 4 times 1. I know enough to know that 2 and 2 wouldn't make a middle term of 3. So it must be a 4 and a 1. And then I just try to figure out where, but don't think too hard. Just try it. Negative 1x, positive 4x. And did that happen to work? Yup, it worked. If it didn't, I would have got negative 3x, and then I would have to switch my signs. Okay, cool. Did you realize we just found x equals 1 and x equals negative 4 are the two x-intercepts? You with me so far? So if I graph this, you don't have to do this. I'm just trying to tell you. We just found the two spots that go like that, and then if it's a normal parabola, it goes like this, and that's really important to know those two spots. Okay, cool. But what if you can't factor it? Like, what if I give you this? X squared plus 3x plus 7. Good luck factoring that one. What do? I said it earlier. Quadratic formula. So everybody take this, and under it, write x equals negative b plus or minus square root. I'm changing colors for this, b squared minus 4ac, because it's really critical today, that little part, all over 2a. Okay, now, the first logical question is, what the heck is a, b, and c? Because they're in this formula all over the place. And are you aware that a is the number in front of the x, which in this case is a 1, and this is b, and this is c? Did you know that? If you didn't know that, that's a big deal. Okay. Now, I think everybody in here knows that the quadratic formula is important because, you know, they made you memorize it. It must be a big deal. And it tells you the x-intercepts if you hadn't figured this out. See how it says x equals? That means it's giving you the x-intercepts. And there's two answers because one will be plus and one will be minus. We saw that in our last problem. We have plus the square root and minus the square root. Okay. But did you know that that b squared minus 4ac part was also super special on its own? Just the red part. It's got its own name. Does anybody know the name of that part? B squared minus 4ac is a famous formula for something. Anybody have an idea? Okay, I know you could look it up, obviously, but that's not. That is called the discriminant. Now, discriminant is a weird word. The base of that is discriminate. And that means to well, I don't have the official definition of that, but it'll tell you something. Okay? It'll tell you a really important thing. This will help you tell if this is the kind that has no solutions, or is this the kind that is got one solution, or is this the kind that's got two solutions? Those are the three possibilities. And let me show you why. Back to what these are. These are parabolas. This parabola has two solutions, because look, it touched twice. This parabola has only one solution, because look, it only touched once. And this parabola doesn't have any solutions, because it didn't touch. That means its solutions are imaginary. Remember the imaginary numbers? If you get imaginary numbers for your answers, then that means it doesn't touch the x-axis. All right, did you process all of that? That's the three ways a parabola can be. You can either touch it twice, it can touch it once, or it doesn't touch it at all. There's no other way it could be. I mean, I could make it up not touching, but that doesn't any different. It's not touching either way. Both the green ones have no solutions, not real solutions. So would you agree that if you're in the middle of a problem with the square root in it, blah, 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 and it's got a square root and you have a negative number, do you get that that's the kind that is imaginary? And that's the green kind, where it's not touching. So if this part underneath here is negative, then there's no real solutions. They're imaginary solutions. Now, what's the other choice? Well, it's either negative or it's positive, right? Well, actually, there's three things it could be. It's either negative or it's positive. Like, let's make it positive 9 for a second. Do you get then? You just have two answers for this. You have a plus and a minus in front of it, and so you'd have plus and minus the square root. And the square root of 9 is 3. There's only one square root of 9. But the reason there's two answers is because the formula has a plus and a minus in it. So this kind, you'll get two answers for it. Well, if it's negative, you don't get any answers. If it's positive, you're going to get two answers. Who can tell me the third thing that could happen? The thing under the root could either be negative or positive or something else, actually. Come on, Stretch, you can do this.
0.
0. Because if it's 0, let's think through the ramifications of this. Do you get, if what's underneath the square root is 0, then the square root of 0 becomes 0. And do you get that the plus and the minus becomes irrelevant? If you're adding 0, do you get it doesn't do anything? Subtracting 0 is the same thing. So that's the possibility where you'll get only one answer. Because the rest of the formula would be happily sitting in front of it, and then underneath it, x equals negative b. Let's say it's negative 8 plus or minus, and it comes out to 0 underneath there, all over 2a, and let's say a is 1, and so then this is just 2. Do you get that when this part drops out, right here, I'm going to circle it in green. If that part drops out, then there is still an answer. It's whatever that was. Because adding 0 or subtracting 0 would do nothing. Okay, so then that part is only one answer. Do you get the plus and minus are gone? So there's three things that could happen with a discriminant. And I know some of you guys like to take good notes. Here's your good notes. You ready? This thing is going to be brought down here, and I'm going to say D for discriminant. B squared minus 4AC. Now, some people are going to, by accident, bring the square root down. Don't do that. The discriminant does not include the square root. So far, do you get the discriminant D is B squared minus 4AC? Now, there's three things that could come out to. D could be greater than 0. The discriminant number could be greater than 0, and therefore you'll get, do you remember how many answers I said? If you had, nope, 2 answers. It's okay. You volunteered an answer, and I appreciate that. D is greater than 0 gives you 2 solutions, because this number, if it's like 9, you're going to get 2 answers because of the plus minus. All right, then there's the discriminant equals 0. Do you remember if it equaled 0, the whole square root drops out and the plus and minus drop out? So how many solutions will you get? 1 solution. If it's b squared minus 4ac turns out to be 0, the square root and the plus minus will all drop out and you'll only have 1 answer. And for extra like your really smart points, if there's only one solution, which of the colors is that? And it's always something very special also. It's not just the solution, it's the vertex. Very good. And it's one solution, and we don't test you on this, but it sometimes comes in handy. You've found the vertex too. The one solution is the vertex. And that's all the cases that there is? No. There's positive, bigger than 0, equal to 0, or less than 0. The third case is D is less than 0. And if it's less than 0, that's the same as negative. And if it's a negative underneath the square root, is imaginary answers. But we would say that there is 0 real solutions. And that means there would be solutions, but they're imaginary. They got a negative under the square root. Those are your 3 cases. All right, so if I give you an equation and you have this in your head, you can quickly figure out how many answers there's going to be. I'll give you the easiest of them all. Would you agree my A, B, and C are 1, 2, and 3? Now, if you're going to do the discriminant on it, in your head, do B squared and subtract 4 times 1 times 3. Maybe this is too much to do in your head. Figure out B squared minus 4AC. And if it comes out positive, you're going to have 2 answers. If it comes out negative, you're going to have no real answers because square roots of negative don't exist. And if it comes out to 0, you get the most special case. If it comes out to 0, your discriminant is 0. That means that your solution is the vertex. In this case, B squared is 2 squared minus 4 times A is 1 times C is 3. B squared is 4 minus 4 times 3 is 12. 4 minus 12 is negative 8. What does that mean? No real solutions. That means that the parabola doesn't touch the x-axis. All right, let me give you another one that's like that. Figure out B squared minus 4AC. If it comes out positive, you got 2 answers. If it comes out negative, there aren't any real answers. If it comes out to 0, the most special case, you've got 1 answer and it's perfect. It's the vertex. B squared is 1. 1 squared is 1 minus 4 times 2 times negative 1. Some people will mess up the negative on this. Final answer comes out to 9. Positive 9. Isn't that a positive number? So how many solutions do you have? 2. And let me show you what they are. X equals negative B. Well, negative B is negative 1 plus or minus the square root. And I just figured it out. That's what's under the square root. So I got that already. So I'm way close to finished. All over 2a, which is 2 times 2, which is 4. And that's my answer. Can you simplify it more? I hope so. Square root of 9, what's that? 3. And if that's really 3, then I got negative 1 plus 3 over 4, and I got negative 1 minus 3 over 4, and I can do both of those. That's 2 over 4, which is 1/2. And this is negative 4 over 4, which is negative 1. And look, I got 2 solutions. 1/2 is one of my x-intercepts, and negative 1 is one of my x-intercepts. Cool. So I want you to realize that when you found the discriminant, you've done most of the work of the quadratic formula. You already know what's underneath the root, and that's the hardest part. So imagine a world where I said I had a discriminant was -8. You can tell me so much stuff already. If the discriminant's -8, what do you know? There's no solution. What does the graph not do then? It doesn't touch the x-axis. Good. And you know that b squared minus 4ac is -8. Okay. Okay. Now we're going to go through these notes real quick. If you had to get this, the first thing you should do is try to factor it. And a lot of kids mess up because they don't do something first. What should you do first? Factor out the 3. Everybody do that. And then see if you can factor it again. I know there has to be one negative, but there can't be two negatives. And 1 has to be a 1 and a 1. Dang, this is not factoring. I mean, the only thing that factored out was the 3. Does that tell me for sure how many solutions there is? No. What would tell me how many solutions there's going to be? The quadratic formula would tell me the 2 solutions, but if I just wanted to know how many solutions are there going to be, you wouldn't use the whole quadratic formula. Discriminant, b squared minus 4ac. Everybody take a second. What's b? Negative, isn't the b the 6? And then b squared is 36 minus 4 times a is 3 times c is 3. And this is 36 minus 4 times 3 is 12 times 3. 36 minus 36. I got the most special one of all. It came out to 0. One solution, and it's the vertex. Cool. How about this one? Well, first you should check and see if it factors, because if it does, take a -2 out. Very good. And it'd be 2x squared minus 5x minus 3. That was tricky. Then does it factor? Because if it factors, you know everything. You know how many solutions there are, and you know what the solutions are. That's why I say if you can factor it, you should. I'm just skeptical that this one's actually going to factor, but it's 2x and x. By logic, there has to be a negative, and there can't be 2 negatives. Otherwise, that would never happen. And then last but not least, it must be a 3 and a 1, and there's only 2 choices. Either the 3 here and a 1 here, or the other way around. So I'm going to check it and see if I, by chance, come out to 5. That doesn't even come close to coming out to 5. So then I should try reversing it, put the 1 here and the 3 there. 3, ooh, there's a chance this is going to work. 2 times 3 is 6x minus 1x. That makes 5x. Is that what I wanted, 5x? Now I wanted negative 5x. So now I can just switch the signs, though. That minus becomes plus. That plus becomes a minus. Yeah, it worked. Now I know there's 2 answers. All right, let's move on. Boom, boom. Go to this page. Page 6 in the notes. All right, this next part is going to blow some minds. Remember how I said if this part here is called the discriminant, and if this part here comes out to 0, then something very special happens? The square root of 0 is irrelevant, and plus and minus it is irrelevant, and all of this gets crossed off when there's a 0 there, because you're finding the vertex Do you remember me telling you that that's the equation for finding the x of the vertex? Do you remember me telling you negative b over 2a? So the discriminant is one of two formulas that are buried in the quadratic formula. X equals negative b over 2a tells you the vertex because this part's 0. And if that's part 0, you're only going to have one solution. And that one solution has to be the vertex. So there's like all of this comes together, and I know you might not see it yet, but it's pretty cool. So you got this equation, which tells you the vertex. The other thing that I scribbled out is called the discriminant, and it tells you how many solutions you're going to have. And this is the key to some of the hardest ACT questions that there are. This is about the pinnacle of like super hard ACT questions, because they'll say like, make me a quadratic that has to have only one solution. And the kid has to know, oh, that's a discriminant formula. So I know b squared minus 4ac, if it has to have only one solution, then b squared minus 4ac has to be equal to 0. And that's the key to solving this really hard ACT question. So I'm just trying to show you this discriminant thing actually does appear in some very difficult questions. All right. If all they asked me was the discriminant, I think we already did this one. Do you remember what it came out to again? I think it came out to 0. So how many zeros? What the heck are they asking me? Those are the same as x-intercepts, and they're the same as the roots, and they're the same as the solutions. When they're asking you zeros, think solutions. How many solutions does it have? 1. And it's the vertex. I'm going to keep on writing it. You don't have to actually memorize that, but it's handy sometimes. Let's do the vertex of this next one. B squared, which is 10 squared, minus 4 times A is negative 4 times C is 6. That's a pain, but I bet I can do it in my head. 10 squared is 100. There's two negatives in there, which makes it positive. 6 times 4 is 24. Notice I didn't like doing it the other way, so I'm doing it this way. 6 times 4 is 24. 24 times 4 isn't that bad. Anybody do 24 times 4 in their head?
96.
36?
96.
Oh, 96. Good. Yes. I thought you answered with such confidence, but you were so wrong. But you were actually right. 96. Now 100 plus 96. Why are you adding, server? Because there's two minuses. Then the answer is 196. What does 196 tell us about how many solutions there are? There's 2 solutions. 2 is the max number of solutions. It's a positive number. You get 2 solutions. This next one, b squared minus 4ac. B squared is 100. Minus 4 times a is negative 1 times c is negative 12. 3 negatives means it's 100 minus something. 4 times 1 is 4 times the 12 is 48. 100 minus 48 would be 52. The discriminant is 52. Some kids sadly say square root of 52. No, don't ever square root the discriminant. The discriminant is 52, period. There's no square roots in your answers. And then that tells me there's 2 solutions. And last but not least, b squared, 16, minus 4 times a is 1 times c is 7. 16 minus 28. Pain in the butt, but I know it's negative. And if it's coming out negative, there's no solutions. No real solutions anyway. Help me. What is it? Negative 8 maybe? I think. No, that's 24. Negative 12? Anybody verify negative 12?
Yep.
Okay. And that's your discriminant, and that negative discriminants mean there's no solution because you can't square root a negative, so. Cool. You've learned everything. Can you sum up what D greater than 0 means about the solutions? Yes, they're the same as the zeros. They're also the same as the x-intercepts. Ethan, what does D greater than 0 mean for solutions?
2.
Correct. How about D equal to 0? 1, and it's the vertex. And D is less than 0? No real solutions. So your graph must look like this. Could look like that. On the graph on this, it would touch like that. Or like that. And the graph on this one, 2 solutions. Could look like that for instance, or it could be upside down. All right, good enough. This is the part where you go to your homework. You have a fair amount of time left, about a half hour, a little less. And if you need individual help, I would happily help you. I think it's a Schoology quiz, but I'm not positive. Could you look? It is? Excellent. Schoology quiz. Let's do the first problem together. It usually is a really good thing to get everybody into the first problem, because then after that, it's not that bad, because you're started. My dad would always say, if you're started, you're halfway done. Violet, could you read me number 1? Okay, no problem. Gray, could you read me number 1?
It's just matching.
It's a matching one.
Yeah, pictures of the graphs, like,
Which graph goes with which? And is it like 2 solutions?
it's like, yeah, D equals 0, D is less than 0.
Okay. So what if it is D equals 0? What's that going to look like? Gray, do you know? The D equals 0 kind?
It's gonna be one solution, so it's gonna be vertex right on.
Yup, kind of like that. Okay, so just matching up those kinds of things. If D is greater than 0, you got 2 solutions, and so it must touch like twice. All right, that's all I got for you for today.